Hey everyone, just to let me know, am I audible? If yes, do let me know. Due to technical fault, I'm late, kids. Everyone, just to let me know, am I audible? Welcome, vanakkam, suswagatam. Kids, just to let me know, am I audible to all of you or not? This is your Baba HSP at your Unacademy NEET English channel, my dear students. If I'm audible, just to let me know, kids. Today, your Baba is going to tell you about alkene, my dear students. But first of all, if I'm audible to all of you, just I want to see green signal in the chat section. I got late because there was technical glitch. Alkene, the unsaturated hydrocarbon, my dear friends. CnH2n, alkene, my dear friends, unsaturated. Before I start this session, my dear students, I want to see that whether your Baba is audible and visible to each and everyone. Do let me know in the chat section, kids. Just for a second, let me see to it whether your Baba, yes, perfectly audible. Chaitanya, very good, kids. That's really awesome. And sorry I got delayed. I got late, kids. Everyone, just show me some fire if you can hear me, can see me, kids. I want to see some fire. I want to see some fire in the chat section, my dear friends. Wow, thank you everyone, thank you everyone, kids, thank you. Now let me start, but before I start, I would like to tell you something, my dear friends. Baba is going to tell you something that everyone, you have to tell your friends that there is really the best chance, the syllabus, the course which is available everywhere for 2 lakh rupees, 1.5 lakh rupees, that is available for 4,999 rupees only, my dear friends. And this is valid just for 2 to 3 days. My dear friends, you can make it possible. You can study with your favorite teachers, the best teachers, I would like to say the best team, that where your Wasim sir is there, your Ambika ma'am is there, your Yava sir is there, my dear students, along with your HSP sir. Wasim sir, the best teacher of chemistry, Ambika ma'am, the best for bio, Yava sir, the best for physics, and HSP, myself, for chemistry, kids. You have to share it to everyone. They can apply code. Code is, let me write down here, code is HSP10. To get maximum advantage, to get the mentorship, just for rupees 4,999, my dear students. It's a very, what to say, kids, nominal price. You can say the registration fees, or once the students they are going to get enrolled, and whatever the GST is applicable, it is less than that. Even less than that, kids. Will you share it to everyone? Just do let me know. If you're already the part of this team, the Avengers team, you can see Is it? Can you see the Avengers team? Avengers team. Just see Avengers team. Avengers team, the best team to teach you kids. Avengers team. At your Unacademy platform. Let me see the chat. Just make a promise that you will do that, kids. Everyone. Just to let me know. I'm good. Ratan bhai, I'm good, kids. So, let me start the topic. So, kids, are you ready? Is everyone ready? So, just move on. We are going to study your favorite alkene chapter, alkene. Remember that alkene is having unsaturation, the pi bond along with sigma bond. Now, I will tell you the preparation of your alkene and the chemical reactions. Everyone ready? So first, I will give you the memory chart so that each and everything you can understand. I will start with the memory chart. First, the memory chart. I will start with the memory chart, kids. What I will give you? I would like to give you the memory chart. What is the meaning of memory chart? That you can say mind map. Baba would like to start with the mind map so everyone, you can feel your organic chemistry that it is going to be very simple, because number of students most of the time they are finding that organic chemistry is very tough, and when it comes to organic conversions they are getting trapped. Most often most of the students, they are not able to understand how to do the conversions. So my dear students, for the best conversions, for doing best conversions and to get full marks, for full marks, what we need? We need mind map. This mind map definitely will make you ahead of each and everyone. Then I will tell you in detail. Then Baba will let you know each and everything in detail. How many of you are ready? If ready with full josh, Baba want to see the fire in the chat section. Everyone, Baba want to see fire in the chat section. Then only Baba will give you mind map. Everyone. No fight, kids. Whenever you want to prove anything, just keep on putting number of emojis, kids, number of emojis. Others will go away. Thank you, Sana and everyone. Just see, Baba is going to give you the memory chart for alkene. Now let's see, kids. Are you ready? Is everyone ready, kids? So see, the memory chart, I will start from here. Calcium carbide. Can you see? Calcium carbide. Now when calcium carbide, this is Ca, C triple bond C. You can see this is the ionic bond and this is the covalent bond. Now, if I put here negative charge, two carbon having negative charges, right, kids? Two carbons, they are having negative charges. Now see to it, kids. If I react it with water, HOH, we know that H is delta positive. So it will react to form acetylene, right? Acetylene. Now our acetylene carbon is sp hybridized. Because this carbon is sp hybridized, my dear students, sp hybridized, more electronegative than nitrogen. So its electronegativity is 3.25. What I'm saying, its electronegativity is 3.25. Now these two hydrogens are acidic. So if you react it with NaNH2, soda amide, NaNH2, so 2 moles of soda amide will react and you will get Na C triple bond C Na disodium acetylide. You will get what? Disodium acetylide. Disodium acetylide. My dear students, you will get disodium acetylide. Now here negative, negative and that positive. Now what we are supposed to do, react it with 2 moles of any Rx. Suppose I have taken Rx, one more Rx, or in place of this you can say methyl chloride. One methyl chloride will take the sodium away, another methyl chloride will take this sodium away. Now 2 methyls will be the part of this CH3, C triple bond C, CH3. You got butene. Now till now we made triple bond, but we are interested in making double bond. Now what you are supposed to do, kids, react this compound with H2PD barium sulfate. H2PD barium sulfate. What is this? I will write charcoal and boiling xylene. Kids. What do you call it? Kids, do let me know what do you call it. Write down in the chat section what do you call it, and is it visible to all of you? Is it clearly visible or not, kids? Just to let me know, is it clearly visible or not? Is this clearly visible or not? I want to see in the chat section, visibility is clear. I think yes. This is known as Lindlar's catalyst. Lindlar's catalyst, kids. Lindlar's catalyst. Now this will give you, yes, cis alkene. You will get cis alkene, CH3CH double bond CH3. Remember that, cis butene. Now if you react it with sodium lithium liquid ammonia, kids, then what you will get? You will get trans alkene. This is very, very important, kids. It's given in your NCERT also. This is given in your NCERT also. Trans alkene. Till now, is it clear, kids? This much is clear to all of you. Let me check it out whether everyone is able to see, kids. Everyone is able to understand. Do let me know in the chat section if it is visibility is clear. Everyone do let me know visibility is clear or not. Now once you got this much, very good, keep on writing, kids, if you are able to understand. Everyone keep on writing. Now see, remember one thing, remember one trick. Everyone just remember one trick, then only you can understand it. TAM, TAM, Tushar, Kar, CSM. If you remember this, then you can do everything, kids. You can understand everything. Just try to put this thing in your brain, so definitely you can understand each and everything. What is this? TAM. Let me tell you the meanings of this, then everything will become simple. T for trans. T for trans. T for trans, kids. T for trans. A for anti. M for meso. M for meso. Meso. Trans. S for syn. Syn. Don't go for the meaning of that. I will let you know in detail. But first of all, just try to understand how to complete the reaction. Now, R means racemic. R means racemic. Now, A for anti, I have told you. C for cis. M for meso. Now, one more thing you have to remember. You have to keep it in your brain that if you add Br2, just remember on adding Br2 will add up according to NT. Why it will show NT addition, I will let you know. Right now, Baba is giving you memory chart. Just focus. Br2 will show NT addition. Just keep it in your brain that Br2 shows NT addition as well as NT elimination. What I'm telling you, NT addition as well as NT elimination also. NT elimination also, kids. NT addition as well as NT elimination. Can you keep this thing in your mind? Right now, I'm not telling you the mechanism. I'm right now just interested in telling you the how to complete the reactions. Kids, can you keep this thing in your brain? Now, one more thing. First, let me complete about Br2. So, if I add to cis, this is cis, and if I add Br2, just focus how to complete the reactions. Kids, just focus. If I add Br2 to this, help me kids, help me. Cis, anti-addition. So, anti-additions, you have just to keep A in your brain, and this is cis. So, you have to keep C in your brain, Ca. Everyone just complete. Everyone just let me know in the chat section, Ca. From there, tell me Ca, what you will write. My dear students, if you are able to understand what Baba is going to tell you, Ca, complete it. If you are the part of this group, complete Ca. Ca, everyone write down in the chat section, complete it. Car, very good. C-A-R, just complete C-A-R. So the mixture will be racemic. You will get here racemic mixture. Now, what is the meaning of racemic mixture? If you know optical isomerism, that the product will be like this. Product will be like this. Definitely you can understand if you know that bromine this side, another bromine this side, H, CH3, CH3. Only legends can understand this. The one who is really studying hard, that kid can understand. Everyone can't understand. Kids, Br, H, CH3, CH3. If one is dextro, then another one is levo. The mixture of dextro and levo is racemic mixture. Now, what I have told you, if you do the elimination also, then it is anti-elimination. That means, if you come back from there, if you reacted with alcoholic KOH, remember that the reverse reaction KOH, alcoholic, then you will get back heat, because addition of Br2 is anti as well as elimination is also anti. So CTAM, you can write down MAT, opposite of TAM means no, it's not TAM, it is CAR, race, racemic anti-elimination. So you will get cis compound. Clear? This one is clear. Let me see in the chat section, my dear students. Is this point clear to all of you? First of all, do let me know, is this much clear to all of you kids? Everyone just do let me know, is this much clear to all of you? Show me the green signal if till now it's clear to each and everyone kids. If till now it is clear to each and everyone, just show me the green signal, everyone. I want to see green signal, kids. Baba want to see green signal. If till now it's clear to each and everyone, kids. Mahira, very good. Chaitanya, very good. And kids, if you're really liking this memory chart, show me something that yes, show your gesture, show your gratitude that yes, this memory chart. Now see, this is transalkene. If I add bromine water to this, now help me what you will get. Just try to understand. This is trans. This will show anti-addition. So complete it. Let me take the first letter. First letter is T. Second letter is A. Just complete TA. What I should write? TA. Write down in the chat section. What should I write? TA. TA. What should I write? I want to see in the chat section. TAM. Very good. TAM. M means meso. So completing it, you will get TAM. The product will be meso. And meso product will look like this. This compound will have plane of symmetry. Just see. This compound will have plane of symmetry. So although it is having two chiral carbons, one chiral carbon, second chiral carbons, two chiral carbons. My dear students, it is having two chiral carbons along with plane of symmetry. This is dividing this compound in two equal parts. That's why it is known as meso, because it is having plane of symmetry. And this is one memory chart. You can take the screenshot of it. Now, after this, Baba will give you another memory chart. This way is the best way how to study, kids. Only in this way you will get the best marks, Now see, kids. Second memory chart I am going to give you. Just see to it, everyone. Just see to it that if I start once again with CH3, C triple bond C, CH3. Now help me, kids. If I react it with Lind-Larsen catalyst, kids, what I will get? Just to let me know, help me out. Lind-Larsen catalyst, what I will get? Write down in the chat section, everyone. If you want to get full marks, what you will get? With the Lind-Larsen catalyst, you will get CH double bond CH, CH3. Lind-Larsen cis. Remember that cis. You will get cis. Now let me tell you one tough thing. The same thing you will get nickel boride P2 catalyst. This is known as nickel boride. Ni2B, nickel boride, also known as P2 catalyst. This is known as P2 catalyst. Here also you will get cis alkene. Both will give you cis alkene. Now, my dear students, if I tell you that you react it with Birch reduction, if you do Birch reduction, what is that? Birch reduction, what is that? My dear students, right now I have told you that reacting it with sodium, lithium, liquid ammonia, you will get transalkene. Are you getting my point, kids? Is everyone getting my point? Transalkene. Now, kids, let me tell you, this is transalkene. You can write like this or you can write like this, kids. Transalkene. Now this is your transalkene. Trans. Now, my dear students, this is cis, this is trans. About Br2 already I have told you. Now Baba is going to tell you something else. You know Bayer's reagent. Do you know Bayer's reagent? What is Bayer's reagent? Bayer's reagent. Bayer's reagent. What is Bayer's reagent, kids? Let me tell you. 1% cold dilute alkaline KMnO4. 1% cold dilute alkaline KMnO4 is known as Bayer's reagent, and it will do syn addition. What is syn addition? What is the meaning of syn addition? I will not tell you right now, but you have to remember that what it will do, it will add 2OH. It will add 2OH. What is the function of it? Remember that if anyone is asking what it will do, it will add 2OH wherever you are getting double bond. Wherever you are getting double bond, it will add 2OH. Suppose if I give you CH2, double bond CH2, and if anyone is going to add Bayer's reagent kits, now what you will get? CH2OH. Now if anyone is going to ask, hey, what Bayer's reagent is going to do, just remember that you have to say, hey, I know that Bayer's reagent will add 2OH. Now see, what I'm telling you, the point you have to remember, my dear students, only one point is required to remember, that it will do syn addition. Which addition? Syn. Just remember syn. Everyone, are you getting my point? Syn. Now see, if anyone is going to give you a question that this is reacting with Bayer's reagent, now what should be the answer? Now if you remember what Baba has told you, that Bayer's reagent will do syn addition. Which addition? Syn addition. So you should remember syn. So cis, syn, CS, complete it. What trick I have told you, I want to see in the chat section. Just try to complete it. CS. What you will write? Happy Janmashtami, Chaitanya. Happy Janmashtami, Chaitanya. Very, very happy Janmashtami. Happy day, Lord Krishna's birthday. Tell me, complete it. Syn, CS. Try to complete it. CS. What should I write? I have told you the trick on the next page. Previous page. CSM. Very good, Sahana. CSM. That means CSM. Complete it. Answer will come out CSM. That means meso. You will get meso as the product. Now what is meso? Meso means two chiral carbons along with plane of symmetry. So product will be like this. This is going to be your product. 2OH with the plane of symmetry, along with the plane of symmetry, 2OH. This is your answer. It is having plane of symmetry. Can you see? If I divide this compound, this will get divided in two equal parts, although it is having two chiral carbons. You got it, everyone? Now same Bayer's reagent, if I am going to add over here, if same Bayer's reagent kits, if I add over here, what you will get? Bayer's reagent. If I add at this point Bayer's reagent, what I will get, kids? Definitely try to see T, S, fill it. Everyone just complete it. T, S, R, Tushar, racemic mixture. I will get racemic mixture. So racemic mixture is like this. 2OH on opposite side, I will add OH, and its mirror image, non-superimposable mirror image. So this will be my product. I hope that everyone got it. This is known as racemic mixture. Racemic mixture. My dear students, In this way, if you are going to study, no one can stop you by getting full marks. Now, how many of you are really liking it? Otherwise, Aisha, Chaitanya, Assalamu alaikum to all Dar Adu. Kids, do let me know if you are really enjoying it. If you think that yes, Baba is doing a great job, show me your gratitude. Do let me know with the green hearts in the chat section. Hit the like buttons, kids. Kailash Yadav, Sahana, very good. Everyone, hit the like button if you are really enjoying it. Kalesh, Aisha, very good, very good. Now, Baba is going to tell you each and everything, kids, each and everything. Just see, Baba will give you the number of memory charts so that you can understand each and everything. But before that, now let me tell you the preparation of alkene. Baba is going to tell you the preparation of alkene. Are you ready? So I am going to move with preparation of alkene. Preparation of alkene. Preparation of alkene. Are you ready, kids, for the preparation of alkene? So let me start with first acidic dehydration. Acidic dehydration, first way of formation of alkene. Acidic dehydration. That means the loss of water in presence of acid. What is the meaning of this? Loss of water in presence of acid. This means loss of water in presence of acid. In presence of acid. Loss of water in presence of acid. And the well-known example of this is CH3 CH2OH, ethanol. If you treat ethanol at 443 Kelvin, 443 Kelvin with concentrated H2SO4, concentrated H2SO4. Mainly it is written like concentrated H2SO4, but you can also take concentrated H3PO4. Doesn't matter because you need acid. So you'll get CH2 double bond CH2 plus water and plus H2SO4. Now, my dear friends, let me tell you one thing. If you supply temperature, the reaction will go in the forward direction, but at the same time, you know that this water and H2SO4 will become dilute H2SO4, and Le-Chatelier's principle is applicable. Le-Chatelier principle says if you add dilute H2SO4 to this, then once again you will get what? You will get ethanol. You will get CH3, CH2OH. So this is a reversible direction. This is dehydration, my dear friends. First one is dehydration, but the second one is hydration. This one is hydration, my dear friends. Hydration. They are reversible reaction. Kids, you are able to understand? Just to let me know. Is this point clear to each and everyone? Dehydration and hydration are reversible. Dehydration and hydration are being reversible, kids. Now, let me tell you the mechanism, my dear students. Let me tell you the mechanism of this reaction. It's not E2. It will follow, kids, dehydration's even mechanism. Now let me tell you the mechanism. Just try to understand the mechanism of this reaction, kids. Mechanism. First step is H2SO4 will break, and H2SO4 will break to give H positive and HSO4 negative, my dear students. Now this is known as proton. Definitely this proton will attack on ethyl alcohol. That is the second step. CH3 CH2OH, this lone pair being attacked by the proton, that is electron deficient, and here we are having electrons. So that proton will come and will say, hey, I want to attack on your lone pair, I'm being electron deficient. So oxygen will be attacked by that proton, and that will get changed to like this, CH2O positive H, and this will be known as oxonium ion. What do you call it, kids? Oxonium ion. If our carbon is having positive charge, we will say carbonium ion. If oxygen is having positive charge, we will say oxonium ion. What do you call it? Oxonium ion. Oxonium ion. The reaction is being reversible, kids, in both the direction. Now, oxygen is saying, hey, I can't tolerate this positive charge. I want to eliminate out water. So definitely oxygen will get eliminated out as water. It will take electron of this carbon and it will eliminate out. And now the carbon will start crying, hey, I have lost my electron. Now this carbon will ask to another carbon, hey bro, help me, I have lost my electron, I want your help. So see how this carbon will help him. CH2H, CH2 positive. Now we know that hydrogen belongs to both the two groups. It belongs to halogen as well as alkali metal. Now HSO4 negative will come. HSO4 negative will come and it will say, I wanna take this proton, and it will take this proton and eliminate out, and this will develop negative charge. Negative and positive, they will form bond. In this way, reaction has been completed, kids. In this way, we have got alkene. This is proceeding towards oxonium ion formation. Intermediate has been formed. Once the intermediate is formed, we will say reaction is following. This is your rate determining step, and it follows E1 path. In many books it's written E2, but remember that NCERT writes it follows intermediate formation. So we will say it is following E1 path. Gets clear? Let me see what's going on. Sahana, Chaitanya, very good. Now let me tell you something more, some tough questions. Now if examiner is giving you this question, just see, always easy questions will not come, kids. If examiner is giving you this question, just see to it. CH2OH, and he has given you concentrated H2SO4, concentrated H2SO4, and some heat is being provided. Now what you will do, kids? Remember that if you know the mechanism, you can find out any product. It's not always just to cram it. You should have brain. If you apply brain, you can find out the product immediately. Now see, it will release H plus. It will throw its H plus. Hey, I'm an acid. I will put H plus. I will throw my H plus, and it will attack on your lone pair. So this H plus will attack on the lone pair of oxygen. Now see, what you will get? Definitely there will be the formation of oxonium ion. What it will form? It will form oxonium ion, CH2O positive, H and H. Oxonium ion formation will take place. Oxonium ion formation will take place. Now everyone say, oxygen will say, I cannot tolerate this positive charge. I want to eliminate our water. Hey everyone, I'm taking your electron, it will move out like this. I can't tolerate this positive charge. It will say, I can't tolerate this positive charge. I will move by taking electron. I will go by taking electron. It will move out. It will move out. Let's move here. Let's move here. So water will eliminate out and there will be development of positive charge. Hey kids, positive charge has come to on that carbon. Now carbocation has been formed. Whenever the carbocation is formed, always think about rearrangement, kids. Whenever the carbocation has been formed, everyone just say, shout, I will think about rearrangement. Whenever, remember that carbocation formation says, whenever carbocation is formed, carbocation is also known as carbonium ion, and carbonium ion says, whenever I'm getting formed, my lord, always think about rearrangement. So it will say, just everyone think about rearrangement. Now when the rearrangement will take place, it all depends. When on doing the rearrangement, stability is going to come. Without stability, rearrangement will never come. Let's see. Hey, what do you want? This ring is saying, I'm 5-membered ring. Anna, I want to become 6-membered. I'm not feeling stable. Oh, so you want to say 6-membered ring is more stable than 5-membered ring is more stable than 7-membered ring. This is the stability of ring, kids. Stability of ring. This way the rings are stable. Remember that 6-membered ring is more stable than 5-membered, which is more stable than 7-membered. So see, I will tell you how the ring expansion takes place. This is 5-membered ring. Just see to it. Let me zoom in and just see from where the bond is going to break. Now the bond will break like this. This carbon is saying, hey carbon, I want to break this bond. The lower carbon is saying, I will take your electron like this. I want to take your electron and I will develop negative charge, partial negative charge. And you will develop partial positive charge. Carbon is saying, why are you taking my electron? In this way our bond will be broken up. Carbon is saying, just wait and see. Wait and watch. I will break this bond from your side and simultaneously I will make bond with that carbon. Ta ta ta, ding 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 ding. Tang ta tang, ding 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 ding. Breaking of bond, making of bond, mob, making of bond, breaking of bond, everyone, bob and mob. From here the bond is breaking and their bond is making of bond, breaking of bond. Just see how this is happening. Because ring expansion is not easy job. Just try to understand. This has gained negative charge, that has lost electron positive charge, and that was already positive. Now this will say, hey dear, I want to join you. Will you support me? I want to make a bond with you. So see, it's like this, and the bond has been made. Just try to understand, my lord. In this way, new bond has been formed. And here is positive charge. You can see like this, or you can write it like this. They are same. They are being same. Now, finally, what is going to happen? HSO4 negative will come. Hey, I need my proton. Please help me out. So just take your proton. I will develop negative and positive charge. and in this way the product formation has taken place. This is your product, kids. This is your product. Everyone just see the whole mechanism Baba has written. First of all, do let me know if you are really liking it. The mechanism is clear. If the mechanism is clear, kids, everyone just to let me know this mechanism of ring expansion is clear to each and everyone. If yes, smash the like button, hit the like button. This is the way Baba is going to give you the best quality content. No other channel, nowhere you will get. Very good, very good. Don't worry, our army will be coming. Bob and Mob, very good. Everyone, now see kids. This is the way that reaction is going to take place. So we have got formation of alkene. Everyone got it? If yes, if you're liking it, then show me the green hearts, kids, or fire in the chat section so that Baba can understand. Now, one preparation you have done. Now the second preparation, I am going to tell you how the alkene can be formed, how to form the alkene in another way. Just see kids. One was the acidic dehydration of alcohol. Now second way is from alkyl halides. Second preparation is from alkyl halides. Second is from alkyl halides. Now how will you prepare from alkyl halides? Kids, there are two ways to prepare alkene from alkyl halides. What are these two ways? One is E2, another one is E1. Hey kids, E2 and E1, these are the two methods by which you can prepare. Now see, the same alkyl halide I will take same alkyl halide CH3, CH, Cl and CH3. Let me write down like this, CH3. If I react, this is being 2 degree alkyl halide, 2 degree. Why it is being 2 degree alkyl halide, kids? Because we can see clearly the halogen attached to the carbon. This carbon is attached to further 2 carbons. That's why we'll say it is 2 degree. This carbon is attached to one this carbon, another one this carbon, 2 degree alkyl halide. Now if I react it with strong base like C2H5ONA, how to find out this is being a strong base? How to find out this is being a strong base? Because in between oxygen and sodium there is ionic bond. So I will say it is strong base as well as strong nucleophile. Simultaneously, it is strong base as well as strong nucleophile. Strong base as well as strong nucleophile. It is both strong. Now, both strong. How it will form the product, I will tell you, but it will do whatever it is going to do, it will do in single step. That means single step means it will do SN2 as well as it will do E2. Remember that substitution as well as elimination, it will do 2 things. But right now Baba is interested in telling you the alkene formation. E2, alkene formation is major. Alkene formation is major. Alkene formation is major. So major amount of alkene will be formed. You will get CH3, CH double bond CH2. This product you will get. Now if I treat it with some weak nucleophile C2H5 and heat, now it will follow the path E1 path as well as SN1. Now right now I am not interested in substitution, I am interested only in elimination. Once again the product will be same, but it will take place formation in 2 steps. So it is single step reaction, it is multi-step reaction. Let me tell you kids, it is being multi-step reaction, that is being single step reaction, single step. Now kids, what is the use of telling you that it is going to follow even path or E2 path? Let me tell you, there is difference. If E2 is reaction, E2 reaction is taking place just in single step, that means no intermediate is going to get formed. But during E1 reaction, your intermediate will be formed. Now let me tell you what is the use of that. Just see, if I write down compound CH3, how they can ask you the question, kids. See how they can trap you. CH2Br, and if I write here C2H5ONA, as I've told you, in between oxygen and sodium there is ionic bond, and due to formation of ionic bond, this is a strong base as well as nucleophile. Now it want to do reaction in single step. Now see, the carbon to which halogen is attached, this is known as your negative, positive alpha carbon, and just on the beta carbon there is no hydrogen. No hydrogen on beta carbon, no hydrogen. That means it can eliminate out bromine, it will get plus charge, but there is no hydrogen, so no reaction. No reaction kids. No reaction means no reaction, no E2 reaction. Product will not get formed, there will be no reaction at all. Are you getting my point? But if I put weak nucleophile like C2H5OH and heat, now the reaction will take place because carbocation formation will take place. First this will eliminate out, it will form carbocation CH3, 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 CH2 plus. Now kids, whenever the carbocation is formed, always think about what Baba has told you. Just to let me know what your Baba has told you. Whenever the carbocation is formed, always think about what I have told you. Always think about what? About rearrangement. Always think about rearrangement. Now see kids, 1,3 methyl shift will take place. This methyl will move from this carbon to this carbon, and you will get CH3, CH3, positive, CH2, CH3. Now my dear students, the carbon which is having positive charge alpha, beta is there, and this beta they are same, but that is different. So you will get 2 types of alkenes. What are these 2 types of alkene? One alkene you will get CH2 double bond C CH3, then CH2 CH3. One alkene is this. Another alkene will be plus charge and beta, that means you will get CH3 CH3, C double bond CH, CH3. Now which is major, which is minor, that we have to find out. Just see to it, major and minor. See everyone, how to find out major and minor. This alkene is having just 3 and 2, 3 plus 2, 5 alpha hydrogen atoms, and this alkene is having 3, 3 and 3, 9 alpha hydrogen atoms. So this is your major because it is more stable. Kids, you got it? Till now, is it clear? If yes, show me the green signal. Yes, that it is clear to each and everyone, kids. If this is clear, thank you, Sahana, Rocky, Tashwin, thank you. Very good, Kevin Kumar. Everyone, just do let me know if it is clear or not. If yes, show me green hearts. Everyone, now let me tell you some more preparations, and then Baba will let you know the chemical properties of alkenes. Now, till now, whatever I have told you, this is known as dehydrohalogenation. Dehydrohalogenation. What it is known as, kids? Dehydrohalogenation. Dehydrohalogenation, kids. Now, I've told you here in dehydrohalogenation reaction, your X should be either chlorine, bromine or iodine. Either chlorine, bromine or iodine. Just remember, chlorine, bromine, iodine. Let me tell you, kids, clear cut. Whenever you are going to deal with reaction RX, and you are going to do dehydrohalogenation, remember that, dehydrohalogenation. Now, if you want to get full marks, if you want to get rank, then you have to study in detail. Now, the question arises that Sedgwick product will be major or Hoffman product will be major. Remember that Baba will let you know very, very important thing, which will be major. That is the most important question. Remember that. If you are doing reaction, that is E2. In E2, mostly Sedgwick product will be major. Mostly Sedgwick will be major. Sedgwick is also known as JETSEP. This will be major, kids. But remember that in this reaction there are 3 special cases. How many? 3 special cases where even Hoffman can be major. Remember that. This is the $1 million question. In this, there are 3 cases, 3 very, very special cases where either Hoffman or Sedgwick can be major. Sedgwick can be major. Now you must be thinking, what is Hoffman and what is Sedgwick, kids? You must be thinking, what is Hoffman and what is Sedgwick? Baba will let you know. Now, if you deal with even reaction, in even, always Sedgwick will be major. Always Sedgwick will be major. Now, where we have to focus, where we have to give more importance, definitely we have to think about E2, because E2 is the game changer. That can change the game, kids. That can change the game. Now, how many of you are interested in knowing about it in detail? Just do let me know in the chat section. In detail. I want to see the chat. How many of you are interested in understanding in detail? Avinash, hello, Avinash, welcome, vanakkam, Avinash, welcome, Avinash. Do let me know. How many of you want to know in detail? Do let me know. Okay, now see kids, Baba is going to tell you this thing in detail. Just see to it kids, everyone, just see. E2. The first example I am taking from NCERT. Example of NCERT. Exactly same example I am going to take, which is given in NCERT. CH3, CH2, CHBr, CH3. I would like to say, don't take Br, you can take any halogen other than fluorine. Let me write down halogen other than fluorine. This X can be either chlorine or bromine or iodine, not fluorine, because if it would have been fluorine, then it will change the game. So I will let you know what if fluorine. First of all, let me take halogen. The halogen attached to the carbon is known as alpha carbon and adjacent carbon are known as beta carbon. Beta carbon. What I am saying? The carbon to which halogen is attached is known as alpha and adjacent one beta. Now why I am telling you? You will come to know that that is important thing. Now either you can take KOH alcoholic heat, or you can take sodiamide, but see kids, what is going to happen? Once this halogen is eliminating out, proton can go from here. If it is going from here, it will form double bond over here. If it is going from here, it will form double bond at this place. Now see kids, what you are going to get? You will get two types of product. Just focus on these two types of product. I will tell you the mechanism also. This is one product and another one product is like this: CH3, CH2, CH double bond CH2. Am I right kids? Am I right? Let me call it A, let me call it B. This is your A, that is your B. Now see this alkene. If I talk about this alkene, you can focus at this point. This is alkenes double bond. That side is one group, this side is one group. That I will say it is di-substituted. One side substituted, another side substituted. So this product is di-substituted. Everyone, you are able to understand di-substituted. Now, if you are able to understand, then tell me that one is, this is your alkene part and there is only one alkyl group. So this is being mono-substituted. Are you able to understand? If yes, tell me yes. Everyone able to understand? Mono-substituted. So kids, the more substituted alkene is, known as Sedgwick alkene. More substituted, that is mono, this is di. So definitely di is being more substituted. More substituted comparatively. Substituted and more substituted is known as Sedgwick product. Sedgwick. Scientist name Sedgwick. People have given another name Jetsep. Jetsep. Just like Mohandas Karamchand Gandhi and Bapuji. And less substituted is known as Hoffman. First of all, tell me that Sedgwick and Hoffman is clear to all of you. Now, this Hoffman product is formed 20% and the Sedgwick formed is 80%. So definitely this is major, that is minor, and both of these two are having relationship that they are structural isomers. Position is different, so they are structural isomers. And my dear students, remember one thing very clearly, This type of thing in science is known as whenever two types of structural isomers are formed. One is in major amount, another one is being minor amount. This is known as regioselective. In science, the word is regioselective. Everyone say what word Baba is using. What I'm saying, kids, regioselective. Regioselective. What is the meaning of regioselective? Everyone say, out of more than one structural isomers, if one is major. So let me write down, if one structural isomer is major, when one structural isomer is major, the word is regioselective. Once again, everyone say regioselective. Clear to all of you, regioselective word. Is it clear, kids? Regioselective. Now, let me tell you, kids, this double bond is dead. Dead for what? Can't show GI. Can't show GI. This double bond cannot show GI. That's why dead. But this double bond will show GI. Will show GI. Will show GI. Now, anyone is asking how many products? So, if that examiner is asking that excluding stereoisomers, then 2. But if including stereoisomers, so this will exist in 2 forms. What are these 2 forms? Just see, kids. Once again, I am writing that this was your reactant CH3, CH2, CHX, CH3. It has formed 2 types of products. You know very well that it was reacted with KOH, alcoholic, and heat. It has formed 2 types of products. What are these? One was CH3, CH, double bond CH, CH3, and another one was CH3, CH2, CH, double bond CH2. This was Hoffman product, and that was Setjep product. Am I right, kids? Till now, this is your Setjep product. Am I right, kids? Setjep. Now, this was major 80%. Now it will exist in 2 forms. This will exist in 2 forms. What are these 2 forms? Just see to it. You will recognize it if you have knowledge. CH3, CH, double bond, CH, CH3. This is known as transform. Transform will be major than cis form. Just try to understand cis form. Why transform is major than cis form? And last, it will be but-1-ene. But-1-ene will be least amount. So this is the product formation. This is cis, that is trans. Now see why cis is less than trans. 2 bulky groups are on opposite side of this double bond. So steric hindrance is least. Steric hindrance is least. Steric hindrance is least. My dear students, least steric hindrance. Here, more steric hindrance. So both of these 2 are Setjep products. Setjep product, but out of these 2 Setjep product, the trans one is major. Till now you are able to understand. If yes, show me green hearts, then I will let you know something more. Jyoti, welcome. Jyoti, welcome. Calvin Kumar, kids. Till now, only Sahana was fighting. Now Jyoti is also there. Jyoti, you have to help Sahana. Sahana was fighting with some people because some people were fighting with Sahana. So, you have to help Sahana. Wow, Sahana, thank you. Mahira, thank you. Now, let me tell you, these 2 products, they are stereochemistry products. That means they are stereoisomers, they are diastereomers. These two are diisomer, and there is one word used by scientists. What is that word? Let me tell you, kids. These are stereoisomers. One stereoisomer is formed in major amount and another one is formed in less amount. So we will use, yes, which word? Tell me, kids. When two structural isomers were formed, one was major, one was minor, we said regioselective. But here we will say what? Stereoselective. What we will say? Stereoselective. Stereoselective. We will say stereoselective. This word is new word, stereoselective. Remember that. Stereoselective. So everyone just say E2 reaction is regioselective as well as stereoselective. Everyone, E2 is regio as well as stereoselective. Stereoselective. Now, my dear friends, I've told you one thing very clearly, that if you do this reaction, just see, examiner will give you this question: CH2Br, CH2Br, and he will give you NaNH2, soda amide, NaNH2, X moles, X moles. Now the question arises, how many moles of soda amide will be consumed? How many moles of NaNH2 will get consumed? NaNH2 will get consumed. Tell me, kids. Now the ball is in your court. This is the question. Ball is in your court. The name of this compound is ethylene bromide. Its name is ethylene bromide. Ethylene bromide. Just to let me know what's your answer. I want to see in the chat. Let's see who is going to give the correct answer, kids. Do let me know. Who is genius? Let me talk. Let me see. Everyone, just to let me know. Let's see who is going to give the correct answer. Baba is waiting for your answer, kids. Everyone, just to let me know what answer you are going to give. Baba is just waiting for your answer, kids. Baba is just waiting for your answer, kids. So, let me see what answer you are going to give, kids. Baba is waiting for your answer. Everyone, everyone. Yeah, billionaire thinking, you are right. I have got one answer correct. Billionaire thinking has given the correct answer. 4 is the correct answer. Answer is 4. Now tell me and just see to it why answer is 4. Correct answer is 4. Just see to it, kids. One NaNH2 will come. One Na will take this Br negative 1. Then there will be plus charge. Another NH2 will come over here and that will take proton from here. Now what you will get? Negative and positive double bond. One will give you this thing. Just see, you will get CH Br double bond CH2. Vinyl bromide, you will get vinyl bromide. Now kids, another NaNH2 will come. Another NaNH2 will come. The second one, Na plus NH2 negative. Na plus will take away this bromide negative, ta ta ta, ding 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 ding, it will get positive charge. NH2 negative will take away this proton, so it will get negative charge because it will take electron, negative and positive bond. Now you got CH, triple bond CH. Till now dehydrohalogenation reaction has taken place. Now 2 moles of NaNH2 will come, NH2 negative, acid-base neutralization, acid-base neutralization, NH2 negative, acid-base neutralization, acid-base neutralization. So you will get finally disodium acetylide, disodium acetylide. So kids, 4 moles of NaNH2 has given disodium acetylide, disodium acetylide, kids. Have you got it? Is it clear, kids? Just do let me know. Is it clear to all of you, kids? Do let me know, everyone. Everyone, is it clear? Do let me know, kids. Got it? Yeah. 2 times dehydrogenation and 2 times acid base. Billionaire thinking your answer is absolutely correct. Very good, very good. That's really fantastic. Now, let me tell you, kids, if in place of halogen, if there would have been fluorine, just see, if in place of other halogens, I have told you they were chlorine, bromine, iodine. If it is fluorine, then what is going to happen? See, kids. Fluorine. Now, if you put NaNH2 negative, now remember that carbon belongs to second period. It is 2p and this is also 2p. So this bond is very, very strong bond, kids. Very, very strong bond. Hey, I'm not going to break. Carbon fluorine bond is very, very strong bond. So it is saying, hey, I will not break. No one can break me. So what this NH2 negative will say, I will take proton from here. It will say, I will take proton from here. I will take proton from here. So it will take proton from 2 places. One proton, this one, another proton, this one. So NH2 negative will come. Hey, I am coming. I will form bond with you. I will form bond with you. Once this is going to form a bond. So here it will try to form a bond. So this H positive will go and there will be development of negative charge, but not the complete negative charge, gets partial negative charge. So kids, remember that this is the $1 million point, kids, that partial negative charge. So I would like to say this will be the formation of what? Let me draw it and let me tell you and let me explain it, because this is going to be the most important thing. It's breaking from here, CHF. This bond is also getting broken up from here. It simultaneously it is forming bond with whom? It is forming bond with nitrogens, this thing. Now see, just try to understand. Just try to understand. Number of things are happening over here. Just see, number of things are happening over here. Just try to understand. Then I will speak. Then I will tell you. But just try to see. Number of things are happening at that place. Billionaire question. Yeah, billionaire, you are right. E1CB. Wow, Muhammadi, you are right. E1CB mechanism. This is the only E1CB mechanism, but not in our syllabus. This is known as E1CB mechanism. You're right. E1CB, unimolecular conjugate base elimination reaction, but the name is not in our syllabus. But see, simultaneous breaking and making, and this is the transition state. This is transition state, and in this transition state there is partial negative charge, partial carbon ion. This is not the intermediate, partial intermediate, partial charge, partial carbon ion, partial carbon ion in transition state. Remember that what I am saying, partial carbon ion in transition state. So the rate of reaction is directly proportional to the formation of carbon ion, partial carbon ion. This is going to decide the product, and this is the partial carbon ion formation in the transition state. Everyone, are you getting it, kids? Are you getting it? So rate of reaction is directly proportional. Rate of reaction is directly proportional to partial carbon ion. Now which partial carbon ion, kids? Now kids, just see, this is 1 degree carbon ion, this is 1 degree carbon ion, this is 2 degree carbon ion. What do you think, which carbon ion is being more stable, 1 degree or 2 degree? Definitely 1 degree carbon ion is more stable. So 1 degree carbon ion is being more stable. This is being more stable, more formed, more responsible for product formation. So the major product this time will be your, just see, once the carbon ion is formed in the transition state, that is partial carbon ion, it will start giving electron. It will start giving electron, and the electron will flow towards this fluorine. Now fluorine will show repulsion, and this bond will become weak. This bond will become weak, and once this bond is going to become weak, then it will eliminate out. First carbon ion will get formed, and then it will eliminate out. So first the proton is going, that means it is losing its proton. This is known as acid, and this is going to form the conjugate base. This is going to form conjugate base, and that's why it is known as acid base. And this reaction is, first step is fast and reversible. This step is fast as well as reversible, fast and reversible. Now the major product will be CH3, CH2, CH double bond CH2. Here the Hoffman is major, Hoffman product is major, 80% Hoffman and 20% is ZG product. Now my dear students, by seeing this example, everyone starts thinking that ZG will always be minor in this reaction, but that is not the truth, kids. That is not the truth. Let me tell you, there are a number of examples where fluorine is the leaving group, but then also, just see, fluorine is the leaving group, but then also ZG is the major. Just see this question, kids. Don't cram it. Then fluorine, when fluorine is the leaving group, Hoffman will be the major product. Just let me tell you, kids. So let me take this example here, fluorine, CH2H. Now I am reacting with NaNH2 and heat. Just see to it that NH2 negative will come, and it will take away this proton here, negative charge, this proton here, negative charge, my dear students, here negative charge, and this proton is about to leave. This proton is about to leave. Now kids, this is 1 degree carbon ion, this is 2 degree carbon ion, but remember that if carbon ion is stabilized by resonance, this carbanion is doing resonance with benzene. So this carbanion is doing resonance with this phenyl group. This is stabilized by, carbanion is stabilized by what? Carbanion is resonance stabilized, so degree will not work, and resonance stabilized carbanion is being more stable, and more stable carbanion, more formed, more stable, more formed, more responsible for major product formation. So in this reaction, your major product will be ZJ product. So there is nothing to cram it out. So see, this is ZJ product because it is more substituted, and this time this is major. So don't cram it, kids. I'm telling you, no need to cram it. This is ZJ product, this is major, and this is your Hoffman product, and this is going to be minor, my dear student. This is going to be minor. Hoffman is minor. Till now you got it, kids. I hope that everyone is able to understand it, kids. Do let me know in the chat section. Very good, Sahana, Shubhashini, everyone. Do let me know. Very good. Today Kiran is not there. I can't see Kiran. I can't see Kushiga. Number of students, I think it's raining or it's Janmashtami. Due to Janmashtami, less people are there, kids. Now, these are the things which are going to form alkene. Now, Baba is going to tell you the chemical properties. Should I tell you the chemical properties? Okay, thank you, Sahana. Thank you. Now, Baba is going to tell you. Okay, now Baba is going to tell you one more reaction in which alkene is going to get formed. That is your Hoffman exhaustive elimination. Just see Hoffman exhaustive elimination. Hoffman exhaustive elimination. Have you heard this reaction's name, Hoffman exhaustive elimination, kids? Anyone? Have you heard this name? It's not he-man. It's not he-man. It's just he. Hoffman exhaustive elimination. Now, what is required for this reaction to take place? Let me tell you. Quaternary ammonium salt, quaternary ammonium salt is required. Ammonium salt with at least one beta hydrogen. With at least one beta hydrogen atom. What else is required, kids? That is plus strong base plus heat. Now, what will be the product? So, the product will follow the same thing like even CB mechanism. Our intermediate, better to say not the intermediate, our transition state will be partial negative charge partial negative charge in transition state, just like fluorine case, partial negative charge in transition state. So Baba is going to teach you, kids. Just see. I'm going to give you nitrogen, methyl, CH3, CH3. Just see to it, kids. Nitrogen is having positive charge. This is quaternary, and let me put down ammonium salt. So I will enclose it, chloride, quaternary ammonium salt. I have got quaternary ammonium salt. Now if I react it with well-known base, that is Ag2O, they are going to use plus heat. Now see, kids, what is going to happen? Just see. Nitrogen, this is alpha carbon, this is beta carbon, this is beta carbon. Why I am taking this? Alpha, alpha, alpha. There is no beta. But here I have got beta. So this proton will eliminate out. You will get negative charge. This is 1 degree carbanion. And this is also C. It will go. So negative. This is 2 degree carbanion. What do you think? Which is more stable? Definitely the base will come. And it will try to snatch this proton. This proton will go along with the base, which is being negatively charged, and this will go with this one, this. So see, this is more stable. 1 degree is more stable. So more stable, more formed, more stable, more formed. Now they will start giving electron to this, and there will be repulsion, and then after this it will go positive and negative. So this will eliminate out as nitrogen, CH3, 3 degree amine, and it will form two types of products. One is CH3, CH, double bond CH, CH3. This is your ZJ product, minor one, because here the product stability doesn't matter. What matters is the carbanion stability. Another one is CH3, CH2, CH, double bond CH2, and this is being Hoffman product. This is major one. Hoffman is major, kids. It's being major. Now all the preparation of alkene Baba has told you. Now Baba is going to deal with the chemical reactions. Are you ready, kids? Agreed? Ready, everyone? Just to let me know, everyone. Ready? Good evening. Let's see who is there. Hema, very good evening. Jyoti, Kushka, welcome. Kushka, I was thinking of you only. Kids, now let's move on to the chemical properties of alkenes. Are you ready, kids? Are you ready? Is everyone ready for the chemical properties? I want to show you the chemical properties. I want to know that. Are you ready or not? Is everyone ready? Yes. Now see, kids. Let's deal with the chemical reactions. Chemical reactions of alkene. Kids, chemical reactions of alkene. Chemical reactions. Are you ready, everyone? Show me fire in the chat section if you're ready for chemical reactions of alkene. alkadiene, alkene, alkadiene, benzene. Is everyone ready, kids? I want to know? Yes? Okay, now see. First is ozonolysis. Ozonolysis, the best important reaction, ozonolysis. Let me tell you, there are two types of ozonolysis. Reductive ozonolysis, kids. Reductive ozonolysis. To do reductive ozonolysis, we need which reagent? That is O3, zinc and water. O3, zinc and water. In place of zinc, you can also use dimethyl sulfide. Dimethyl sulfide you can use. And there is oxidative ozonolysis. Second is being oxidative ozonolysis. Here we will use just O3 and water. Remember that O3 and water, both the two types of ozonolysis holds a hell lot of weightage, my dear students. They are very, very important. Now I will start with reductive ozonolysis, because once you know this plays very, very important role. It's being very, very important. If you know this, you can understand everything. So Baba is going to deal with reductive ozonolysis. Are you ready, kids? Reductive ozonolysis. Let me take one alkene, R1, R2, double bond, R3, R4. Now let me react it with O3. You know that O3, ozone, is unstable, thermodynamically unstable. It will attack on the pi bond because these electrons are easily available. These are available, so it will attack. And what you will get? CR1, R2, the R3, R4. And double bond is being attacked by ozone, so it will form mono-ozonide. What I'm saying, it's mono-ozonide. Now see, you can see clearly this is being peroxide linkage. Oxygen is being linked with oxygen -1, highly unstable, kids. Now zinc will come and water will also come, kids. Zinc will come and water will also come, but zinc will say, let's wait and watch. So this carbon will keep one oxygen, this carbon will keep one oxygen, and out of zinc and water, which is having more oxidation potential, this one is having more oxidation potential. Standard oxidation potential is more. So zinc will undergo oxidation and it will take this oxygen. One oxygen will be taken by zinc and zinc will form ZNO. Jan will become Janu and they will become like this. Just see, R1, R2, C double bond O, C double bond O, R3, R4. Now in the examination you will not get this much of time. In the examination time will be less and we have to do a lot. Welcome Jyoti Jayant Kushiga. So we should know the smart trick to solve this question. So how we can do this question smartly? Just see the way how to do it in the fantastic way. My dear student, just see, everyone. Just see to it. break this sigma and pi bond and put oxygen, you will get it. And if you want to make it back, just close it and remove oxygen, you will get directly. Don't go with that long theory part, just opt for the short trick. Immediately you will get the answer. You got it? Just break it and make it. Move it and add oxygen. You will get like this. Now let me tell you how and what I am telling you, kids. Just if I am provided with this compound and you are doing ozonolysis, O3, zinc and water, what you are supposed to do, kids? Just break this bond. Ta-da-da, ding ding. I've broken it. I will add oxygen. Just oxygen I have added. You got it? I hope you got it. Let me show you another compound. Suppose you are having compound CH3, CH, double bond CH, CH3. What you are supposed to do? La la la, da da da. I will break you from here. Kit. Just remove it. Hey, just go away. La la la. I've broken you from here. And you are like this. Got it? Are you getting it, kids? Now, let me give you another compound. You will say, yes, sir, we are enjoying it. Let me give you another compound, CH3, CH3, C double bond C, CH3, CH3, da da da. I don't know very well what to do. I will break from here, separate it, and you will get product like this. How many found it easy? Just to let me know how many of you are enjoying it. Now, one thing was very common to all of these. They were symmetrical alkenes. Once the alkene is being symmetrical alkene. Once the alkene is being symmetrical, only one type of product you are going to get. This is the most important thing. Only one type of product. Whenever the alkene is symmetrical, we will get one type of product, or you can say just reverse of it. You can say just reverse of it. What is the reverse of it? That if we got only one type of product, that means the alkene is symmetrical. That means the alkene is symmetrical. Now let's do one question on the basis of this, so that you can check it out, what you have understood and what you haven't. Kids, just see. If I say compound A, this is being the question. Let's see how much you are able to understand. A gives CH3, CH double bond O plus acetone. Now examiner is asking, what is A? IUPAC name of A. What is the IUPAC name of A? Tell me, let me see in the chats that what you are going to give the answer. Let me check it. Everyone, just to let me know what's your answer. If A has given CH3, CHO and acetone, what is the IUPAC name of the compound? Everyone, just to let me know. What is the IUPAC name? Yes, everyone, just to let me know what's the answer. I'm waiting for your answer, kids. Baba is just waiting for your answer. Okay, Manoj Jain. So, let's see how to do this question. Should I tell you, kids, how to do this question? Should I tell you how to do this question, kids? Should I tell you, kids, how to do this question? Just see. Everyone just see to it. This is acetaldehyde. Now acetone. Acetone is this one. C double bond O, CH3, CH3. Acetaldehyde is this one. Now connect it and join it. And remove oxygen from this. Just remove oxygen from this. If you remove oxygen, what will you get, kids? What will you get? Do let me know what you are going to get. You will get compound like CH3, CH, double bond C, CH3 and CH3. What is the IUPAC name of this compound? Just see. 1, 2, 1, 2. 3, 4. So the answer is 2-methyl but. B will be smaller, but 2-ene. I hope everyone got it. This is the way how to frame out the product. Now kids, if anyone is going to give you ozonolysis of benzene, benzene's ozonolysis. Now let's see how will you do that. First of all, just try to find out benzene is formed like this. What is there? CH, double bond CH, CH, double bond CH, CH, double bond CH. From where the bond is going to break, just see. The bond will break from here, the bond will break from here, the bond will break from here. Triozonide will be the intermediate. Am I right, kids? Triozonide will be the intermediate. And once it is going to react with zinc and water, the product will be breaking from here. So what you will get? Just see to it. CH, double bond O, 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 CH, double bond O. What do you call it? 3 moles of glyoxyl. They are same. 3 moles of glyoxyl, 3 moles of what, kids? Glyoxyl, glyoxyl. I hope that this is clear to each and every one. Each and every one of you are able to understand. But the same question, they are going to give you tougher question. If they give you orthoxylene, orthoxylene will give you how many types of products on reductive ozonolysis? They are going to give you O3, Zn and water. How many types of carbonyl compounds? How many types of carbonyl product you are going to get? Carbonyl products. How many types of carbonyl product? This is the question, kids. I'm waiting for your answer. What answer you will give? Just tell me, kids, what answer you are going to give. So, very good, Sahana. Manoj Jain, glyoxyl, very good. Do let me know, kids, what answer you are going to get for this. So this question is a little bit tougher. So I will give answer from my side, kids. Let me give you the answer. Just wait. Oh, great. Sahana has already given the answer 3 types. Absolutely correct. Absolutely correct. Your answer is absolutely correct. Just see, you will get 2 types of orthoxylene. One having double bond over here, and another one will be like this. This double bond is not fixed, it is delocalized. Once you know this point that it is doing resonance, so the answer will come out immediately. What are you supposed to do? Just you are supposed to break it from here and here. You are breaking it here, you will get CH3, C double bond O, CH double bond O, 2 moles of this from this side and this side, 2 moles of this methyl glyoxyl. This will give you glyoxyl, 1 mole of glyoxyl. Now my dear students, if you break this one, now this will give dimethyl glyoxyl, CH3, C double bond O, CH3, C double bond O, this is dimethyl glyoxyl. And you will get this 2 moles of glyoxyl. So we got 3 types of products, so answer is 3. Now kids, after doing this reductive ozonolysis of alkene, Baba will let you know reductive ozonolysis of alkynes, reductive ozonolysis of alkynes. It's very simple, just see to it. R, C triple bond C, R dash, and if I do reductive ozonolysis gets O3, zinc and water, you will see it is having 2 pi bonds and oxygen needs just 2 pi bonds. So sigma bond will remain intact. You will get R, C, C, R dash, double bond O and double bond O. It's simple. It's simple. Easy peasy lemon squeezy. Just see. If anyone is going to give you question based on this, that CH, triple bond CH, and you are doing reductive ozonolysis, so answer will be CH double bond O, CH double bond O. If anyone is going to give you CH3, C triple bond CH unsymmetrical, then you will get CH3, C double bond O and CH double bond O. It's so simple. So nothing to do with reductive ozonolysis of alkyne. It's very simple. Now let's see what will happen if you are going to deal with the oxidative ozonolysis. What is going to happen? What product formation will take place if you are going to deal with oxidative ozonolysis? So this is also important, oxidative ozonolysis. Just keep my words, kids. It's also going to play a very important role. The same R1, R2, C double bond C, R3, R4, and if I do the ozonolysis, it will form monoozonide R1, R2, CO, COO R3 R4. Now kids, if I'm not using zinc, what is going to happen? If they are not using zinc, because they are talking about oxidative ozonolysis, so they will not use zinc. Now what will happen? Just see. One oxygen will be taken by this carbon, one oxygen will be taken by, and one oxygen, definitely this water will take one oxygen and it will get converted into H2O2. This is mild oxidizing agent, MOA, mild oxidizing agent. Now see, we will get two types of product, that is R1, R2, C double bond O, C double bond O, R3, R4, and plus H2O2. Remember that H2O2 is mild, means weak oxidizing agent, and it will definitely attack on aldehydes. So the effect of aldehydes, we will see this mixture is not stable if any aldehyde is there, and I will write what will happen if aldehyde is there. Are you ready kids? Just to see the effects of H2O2, let's see the effects of H2O2, effects of or the attack of H2O2, hydrogen peroxide. H2O2 will attack it, and let's see what is going to do this H2O2, how the scene will get changed. This H2O2 says, hey aldehyde, I will convert you to the acid. I will make you acid. I can't see you as an aldehyde. I will definitely convert you into acid. Now ketone is saying, hey, what you will do to me? It's saying, hey, I'm not that much powerful. Ketone, I can't fight with you. No effect, no effect, no effect to ketones. Gets no effect to ketones. Now, remember one thing, my dear student, there is one thing that if formaldehyde is there, point to be noted, my lord. Point to be noted, my lord. If formaldehyde is there, H2O2 will attack and it will convert it into acid, formic acid, and then also it will fight with this, my dear students. Remember that this is the only acid with CHO group. Formic acid is the only carboxylic acid in this world with CHO group. Now once again H2O2 will come and it will convert into CO2 and water. It can't see formic acid, this formaldehyde in the form of even acid. It will get converted into ultimately carbon dioxide and water. Now let me give you one question and just try to see whether you are able to solve that question or not. Just see, my dear friends. Baba is giving you a question that the compound is CH3, CH double bond C, CH3, CH3, and if I'm providing O3 and water, just O3 and water, one thing is that no zinc is there. No zinc is there, just water is there. So everyone, you have to say this is an example of oxidative ozonolysis. Am I right or wrong? Everyone, you have to say this is an example of oxidative ozonolysis. Now see, this will break from here. What two products you are going to get? One is CH3, COOH, another one is C double bond O, CH3 and CH3, because ketones are not affected by H2O2. These are the two products. Now, my dear students, if they would have given you reaction like this, CH3, CH double bond CH2, now if you are supposed to react it with O3 and water, now kids, this definitely will give you CH3, CHO, and that HCHO, and plus formaldehyde. Now what formaldehyde will do, kids? Formaldehyde will react, no sorry, H2O2 will react with this, H2O2 will react with this. Now this will get converted into acid, CH3COH, and this will also get converted into acid, but this acid is having what? The aldehydic part. So finally it will convert into CO2 and water. So the final product will be like this, CO2 and water and acetic acid. These are the answers. Okay, just to let me know, agreed or not? Everyone agreed or not? Sir, how could you be are this much dedicated? Boss, thank you. But you see the dedication level of HSP. Baba is always teaching you, kids, whether you like Baba or you don't like anyone. Kids, Baba want to see your success only. I'm not teaching for views. Baba never teach for views, kids. Baba is always there to give you knowledge. Baba never give bad content. Baba is always giving good content, and this is for you, kids. This is for you, kids. Now see, let me give you some more examples of, now let me tell you oxidative ozonolysis of alkynes. Oxidative ozonolysis of alkynes. In this world, there are only few students, those who can understand what is Baba and how much Baba is hard working and how much Baba is working for you, kids. Only few students are there, kids. Only few students, not more students. Now see, kids. R C triple bond C R dash. Now if you add O3 and water, kids, let me tell you, first you will get R C double bond O C double bond O R dash. Now I have told you H2O2 cannot attack on ketone, but my dear friends, these are special type of ketones. Why these are special type of ketones? Because two carbonyl groups are simultaneous on adjacent, so they will get oxidized, whether they are aldehyde or ketone, special ketone or aldehyde, they will get oxidized. They will get oxidized, my dear friends. And finally the answer will be, this is the intermediate, I will say, you will get RCOOH R dash COOH. Remember that whether they are ketone or aldehyde, they will get oxidized. Very, very important thing, they will get oxidized. Thank you, Sahana, Kushiga, everyone, kids, thank you. Now see, let me give you example of that. If you are provided with CH, triple bond CH, if you are provided with CH3, C triple bond CH, if you are provided with CH3, C triple bond C CH3, these three questions, just see the solution of these three. What you are going to get, kids, just see to it. O3 water. Here you will get H C double bond O C double bond O H. This will break to form 2 moles of formic acid. That will further break to form 2 moles of carbon dioxide and water. I've already told you, kids, formic acid is the carboxylic acid which is having CHO group. Now here you will get CH3COOH plus formic acid, and I have told you formic acid will broken up to give carbon dioxide and water. So finally here in this case the answer is acetic acid, carbon dioxide and water. Now in this case 2 moles of acetic acid will be the answer. I hope that you got it. Now I'm going to give you one very important note. Very important note is what? The very important note is my dear students, that just like oxidative ozonolysis of alkenes and alkynes, just like oxidative ozonolysis of alkenes and alkynes, what I'm saying, just like oxidative ozonolysis of alkenes and alkynes, we will get same type of products with KMnO4 acidic medium, or K2Cr2O7 acidic medium. So kids, if you know oxidative ozonolysis, once you know oxidative ozonolysis, whatever the product you are going to get in oxidative ozonolysis, the same type of product. Chandan Kumar, thank you. You are able to understand me. Very good, Chandan Kumar. Only few kids are there, those who really can understand what a teacher is giving you. The content teacher is really giving you, kids. And some people are really very important people. Now this thing I have told you. Now let me tell you hydration of alkene. The second chemical property Baba has told you. Sahana, thank you. Mahira, thank you. Now Baba has told you the ozonolysis. First chemical property I have told you. Now I am going to tell you hydration. The second one, hydration. Hydration means addition of water. Hydration means addition of water. Now addition of water can be done in 3 ways, very important. 3 ways are there. 3 rules are there, 3 ways are there by which you can do. First is acidic hydration. Now in acidic hydration, I would like to say it's not good hydration. It's not a good hydration. Why it's not a good hydration? Because mixture of alcohols is obtained. Mixture of alcohol is obtained. Mixture of alcohol is obtained, so it's not a good method, kids. It's inferior quality of preparation. Mixture of alcohol is obtained because of rearrangement. This is all because of rearrangement. Now why and how, kids, let me tell you. Suppose if examiner has given you this alkene. Now if you want to add water in presence of acid H2SO4. Now see, there are three types of entities. Can you see three types of entities? Alkene is there, water is there, H2SO4 there. Who is the most reactive? Definitely H2SO4 is most reactive. So H2SO4 will donate its H plus, and that H plus definitely will come and attack on this double bond. Now this alkene will be affected and this will form carbocation. Now whenever I see carbocation, my mind always speaks, just think about rearrangement. Everyone think about rearrangement. Whenever I see carbocation, my mind always says, think about rearrangement. Just think about rearrangement. Now, the rearrangement will happen, but before that, attack of water will also take place. So, just the minor product, but yes, minor product will also get formed before the rearrangement. So, let me take another page and let me write down that this carbocation, number of reactants are there, 1000 crore molecules are there. Some will be undergo rearrangement, ring expansion. Some will go ring expansion. Like this 6-membered ring. This will form bond over here. So you will get plus charge at this place. Even this is not that much stable. Why? From here 1,2 hydride shift can take place. 1,2 hydride shift can take place. And you will get this carbocation, the most stable carbocation. And from here only 1,2 hydride shift can take place. Then you will get this carbocation, kids. This carbocation. Now my dear students, wherever the carbocation is formed, just add water. When you add water, oxonoamine will get formed and that will eliminate out proton. Finally, you will get alcohol. So this is the major H2O minus H plus. You will get product. This product you will get, kids. This is your major product. This one will be minor product, kids. This will be even lesser amount, means least amount I can say. And this will also get formed. So see, kids, number of types of product has been formed. The mixture of alcohols, that is not good. Can you see? Everyone, can you understand this mixture of alcohols which is not good? Everyone just to let me know, kids. Jyoti, very good. Yes, yes, yes. Now, yes, everyone is saying CH3OH. One is the least one. That is, if double bond attacks over there only, that is negligible one. I would like to say that one will be the negligible one. This one will be the negligible one. This will also get formed, but this is negligible. Now see, these many mixtures, and in case of alcohol, how the mixture can be good? Mixture can't be good. So scientists, they thought of doing something great. Let's make out something very good. What's that? They have prepared pure alcohol. What's that, kids? What they have done? OMDM, they are singing the song. OMDM. What is this OMDM? Kids, what's this OMDM? Why they are singing this song? OMDM, OMDM. What is this OMDM, kids? Sir, this OMDM means Oxymercuration, demercuration, oxymercuration, demercuration. What is going to happen in this? Let me tell you, kids. Suppose we have taken CH3, CH double bond CH2. Now just remember the reagent. That is very, very important. That is going to play the most important part over here. Kids, follow this. What's that? Hey, I have forgotten about the reagent. Now what should I do? Kids, who is going to tell me the reagent? Which reagent? Sir, reagent. Mercuric acetate, CH3. Champa, where are you? Hey, Champa. Yes, sir, I am coming. CH3CO whole twice Hg, mercuric acetate. THF, tetrahydrofuran, and water. First add this and then add NaBH4. Oh. Hey Baba, this much you have to add. If you are adding this much, you will get pure alcohol. Now pure alcohol will follow Markovnikov's rule or anti-Markovnikov's rule? Markovnikov addition. Markovnikov. Sir, what is that? What do you mean by Markovnikov addition of water? Markovnikov's addition of water. Markovnikov's addition of water. What is this, kids? Let me tell you, this rule says that negative part of the reagent goes to that double bonded carbon which has less number of hydrogen atoms. What this rule says? Marco, hey Marco, what do you say? What do you mean? Hey sir, my mind says that I am saying that, tell me now what? Negative part of the reagent. Negative part of the reagent goes to that double bonded carbon which has less number of hydrogen atoms, which is having less number of hydrogen atoms. So you will get pure alcohol, kids, pure alcohol. In this way you will get pure alcohol. Now the mechanism, right now, should I tell you mechanism? Are you interested in mechanism, kids? Just do let me know in the chat section. Because time is too much. Jyoti, yeah, it is also correct. Whatever, anything of mercury. Mercury is important. Oh, Yaman Sharma, welcome. Welcome, Yaman Sharma, welcome. That's really awesome, Yaman. Aman Sharma, very good. Chandni Kumar, fantastic. Chandan, very good. Now, how many of you want to know the mechanism? Tell me. But it will require time. Can you give time? Do you have time, kids? If you have time, then only Baba can let you know the mechanism. Everyone just to let me know. Manoj Jain, yes. Everyone is saying yes. So, Yaman Sharma, yes, very good. Everyone hit the like button, smash the like button and show me green hearts if you want to know the mechanism. Everyone, if you want to know the mechanism, show me. Yeah, I am okay. I will give you the mechanism. Mechanism is the most important thing. Only legends can understand mechanism. Now see. The mechanism, hey, la. Mercuric acetate, CH3, C double bond O, mercury, CH3, C double bond O, mercury. Mercury was in tetrahydrofuran. Where was mercury? Mercury was living in tetrahydrofuran. What is tetrahydrofuran, kids? This is tetrahydrofuran. Oxygen is there, oxygen. Sir, draw it properly. What is this? Sorry, kids. O, mercury plus tetrahydrofuran. Tetrahydrofuran. It was living over there. This is right. 2 mercuries I have written, kids. Only 1 mercury will be there. Now, water was also there. Now, one day, there was the entry of some alkene. Alkene entered in their society. Now, alkene was rich in electrons, pi electrons. Now, see, kids, this carbon's electronegativity is 2.75. But you see, oxygen's electronegativity is 3.5. Mercury said, hey, oxygen, I don't want to live with you. I'm to going. I want to leave you. So mercury left oxygen. And started moving towards whom? Attacked on alkene. I want to attack this electron. Electron is like money. Both the carbons thought that mercury is mine, but mercury was interested just in money. So mercury has entered in the life of 2 carbons. Both of the carbons were thinking that mercury is mine. So they started fighting that mercury is mine. So mercury asked them, who likes me more? Who loves me more? Just decide. One carbon said, it's okay. If you don't want to be mine, just leave. I'm 2-degree carbon and I'm having support of 1 methyl plus I from my left hand side. But that carbon is saying, oh mercury, I too can't live without you. You are mine. So mercury said, okay, just she started breaking bond from that carbon and water attacked from opposite side. So it is known as anti-addition. Remember that, anti-addition, and that's why it is known as anti-addition. And remember that because of this 3-membered ring, rearrangement can't take place. Rearrangement can't take place, can't take place because of three-membered intermediate. Three-membered intermediate rearrangement can't take place and water will attack. Once the water has attacked kids, you got CH3, CHOH, CH2, Hg, O, CO, CH3. Now if you add NaBH4, OH negative, then in multiple steps, there will be demercuration. Demercuration will take place. And you will get product like CH3, CHOH, CH3. And in this way, this story has got ended. And this is the mechanism, kids. You got it? Do let me know in the chat section, everyone, if you liked it. Do let me know, kids, everyone, you got it or not. Just to let me know. Now, money-minded mercury, yes. The game of money-minded mercury has stopped and carbons have thrown it out. Now, kids, one more way of preparing pure alcohol is there, that is brown hydroboration-oxidation. Agreed, kids? I will tell you the mechanism also because it's very, very important. Everyone agreed? Are you ready to give me some time? Will you give me some time because it's going to be 10? So are you agreed for giving me some time? Then Baba will let you know. Mahira is there, Chauhan is there, Sahana is there. Very good, kids. Very good, very good, very good. Baba is going to give you. Baba. Brown hydroboration-oxidation reaction. Baba is going to tell you brown hydroboration-oxidation. Very, very important reaction. Just see to it, kids. Brown hydroboration-oxidation. HBO. People call it HBO. HBO, the full form is brown hydroboration-oxidation. Brown hydroboration-oxidation reaction. Now, kids, this follows anti-Markovnikov addition of water. This follows anti-Markovnikov's addition of water. And one thing is very, very important, pure alcohol is formed. Pure alcohol without rearrangement is the product. Remember that. Pure alcohol without rearrangement. And this is very, very important. I will tell you detail of this. I will tell you the whole detail about this, the mechanism, because it holds a whole lot of weightage. Remember that if there is CH3, CH double bond CH2, now what we have to use? B2H6, H2O2, or B2H6 first, THF, H2O first, then second step H2O2, OH negative. The final answer will be CH3, CH2, CH2OH. And in this reaction, one thing is very important, kids, that alkene should be taken in excess. Why it should be taken in excess, we will see in the mechanism. Are you agreed? Are you ready, kids? Baba is going to tell you about this, why this should be taken in excess. Let's see the mechanism of it. Let's see the mechanism of it, kids. The mechanism is, first of all, just see to it. Once the BH3 is electron deficient, only 6 electrons in the valence shell. Do you remember this? There are only 6 electrons in the valence shell. Now, it is in need of electrons. This BH3 is in need of electrons. This is electron deficient. So, it will come and attack on CH3, CH double bond CH2. Now, the question arises where it will attack. So, BH3 will attack this carbon. Ta-ta-dan. Why? Why this is going to attack this carbon only? That is the question, $1,000,000 question. Let's see when it is going to attack, you will understand it. CH3, CH, CH2. Now, my dear students, this is applying plus I. Due to plus I, this electron is going toward this side. This is partial negative and this is partial positive, and that is being electron deficient. So definitely it is going to attack on that carbon which is being more electron efficient, and in this way this will have positive charge, and BH3 will come and form a bond with this carbon, and it will get negative charge. Just see, its electron has been transferred over it. Why you're writing, sir, partial negative? Okay, let me write down complete negative. Now, kids, boron's mother said, "Hey, boron, you are very small. What you have done? I told you not to have more than 3 valencies, and you are holding right now 4 valencies. That's not good. Leave one." So, boron decided to leave this hydrogen, and boron is saying, "Hey, carbon, have it." Carbon is saying, "Okay, give me this hydrogen. I'm interested, but I want electron also, because I am electron deficient. I am right now having only 6 electron." Boron said, "Okay, let's do one thing. Let's have 50-50, like Britannia 50. Half of the hydrogen just you keep, and rest of the half of the hydrogen I will keep." He said, "What do you mean? Hey, boron, what are you talking about? Hey, man, you don't have sense." He said, "Okay, let's decide. CH3, CH, CH2. Now this boron, just see, boron, it has transferred its 1 hydrogen over here, and it is making a little bit bond like this. Now, it is having partial negative, and that is having partial negative. My dear students, just see, hydrogen is sharing electron to this, but why this is having partial negative? Only this one is having. Now, this is the 4-membered ring. That's very tough. Now, question arises, why boron has transferred 1 hydrogen to this alkenes carbon? Why not he has broken that bond, the bond formed by that? So, boron is saying, "I can't leave this alkyl group because this is my Anna giving support through plus I, electron donating group." My mother said, boron is saying, "My mother said just to keep 3 in your life. Why to keep hydrogen? Hydrogen is not giving me electron." So he decided to keep alkyl in his life. He is happy. Now he's saying, "Oh, hydrogen, you keep it. I am not in need of. I'm not in need of." Now, why I'm focusing over here? In place of BH3, they would have given you BD3. in place of BH3, if they would have given you BD3, deuterium, then in place of H, deuterium would have formed the bond with carbon. Deuterium would have formed the carbon bond with carbon. Now you see what you get. CH3, CH, CH2, and this hydrogen from boron, and this is BH2. Now boron is talking to his mother. Mother, hey mother, I'm very happy that I have got rid of hydrogen, and in my life some alkyl is there who is always taking care of me by providing me electron. He is very kind, he is very generous, he is electron donating group. Mother started shouting, hey boron, you don't have sense. Boron saying, what happened, mother? What you have done once, do it twice. Remove both the two hydrogens. If you are that much happy, that what you are waiting for, just kick this hydrogen. Hey hydrogen, go away. Now 2 more alkenes in this way. 2 more alkenes, 2 more ethanes. They have come to the life of boron, and now boron is having 3 alkyl groups in his life. 3 alkyl groups in his life, and this is the intermediate trialkyl borane. This is the intermediate trialkyl borane, and that's why I have told you always alkenes should be taken in excess 3:1 ratio. 3:1 ratio. Now there is interval. Now let's see what is going to happen. The trialkyl borane, this trialkyl borane is the intermediate, and number of times it is going to react with H2O2, and then you will get 3 moles of CH3, CH2, CH2OH, but the yield is 95%, the purity is 95%, and then scientists decided to get 100%. Kids, first of all, do let me know in the chat section you are able to understand or not. Are you able to understand? Everyone, just do let me know in the chat section. Hit the like button. If you're liking it, kids, make it 100. What are you doing? What are you waiting for? Smash the like button. Everyone, hit the like button. It's 80. I want to see likes should get increased. Likes to get increased, kids. Everyone, hit the like button. I want to see more likes. Just want to see more. Trialkyl borane. No, trialkyl borane is not stable. Not that stable. It's the intermediate, Jyoti. It's the intermediate. Thank you, Manoj Jain. Thank you, thank you, thank you, thank you, thank you, kids. Now I want to see likes. Likes. Kids, can I take? Jyoti, can you see my doubt, sir? Jyoti, trialkyl borane is quite stable, sir. Yeah, I have seen. No, it's not stable. It's not stable. Kids, can I take 10 minutes break? 10 minutes break. Yeah, I am not having water. Can I take 10 minutes break? Kids, just to let me know. 10 minutes break, can I take? If your permission. Yeah, Kushga, I can understand. I have seen your message. Kushga, I have seen your message. Can I take 10 minutes break, kids? Okay, so right now it is, so let's meet at 20 to 15, means 10:15. Okay. Okay, let's meet after 10 minutes break. Okay, kids? Okay? Everyone, welcome back. Just to let me know, can you hear me, can you see me? Baba is right back now. And kids, I have shared the photograph of Aditya. He got 702 marks in Patna. He has studied on our Unacademy, this YouTube, and he has taken help, and throughout the year he has studied physics, chemistry, biology from all of us kids. He got in Patna, and he is saying thanks for posting my photograph in Telegram channel. Kids, see, I want to tell you that next year you are going to get selected. Definitely your selection is waiting for you. Just your hard work and your lot of smart work you have to do, and definitely you will reach at that place. And my dear friends, I would like to tell you that once again Baba wants to tell you that sharing is caring. Sharing is caring. Make it big. This student has taken admission through this 4999 theme only, kids. 4999 like this. I don't know what was the actual price at that time, but it was like this only. He has taken admission to our platform, Unacademy platform, and he got this rank. Kids, the whole credit he is giving to us because he has studied from us only, from a very, very small town. I have gone over there. I have given the gift. You can see that photograph. It's available in the Telegram channel, kids. So I'm saying just go for this. This offer is available just for 2 to 3 days. August is going to get ended, and after that this offer will not be available. Just you can get the chance to study with Avengers team with only this much amount, my dear students. This much amount, valid only up to August. Just I would like to say 2 to 3 days, my dear students. You know very well our Wasim sir for chemistry, Ambika ma'am, fantastic teacher for bio, Yavas sir for physics, the best teacher, and HSP Baba, myself. Now let me tell you the tricks and the mechanism, whole mechanism. Let me see what you are writing in the chat section, kids. Everyone just see. He got Aditya, let me tell you, Aditya got in the MCC counseling, Aditya got in the first counseling round of MCC, he got AIMS Patna. Kids, everyone congratulate this kid. Baba drove for 12 hours. I have gone to home place. I have given gift, and now I came back, and now I am taking class also, kids. You can't see how much dedicated Baba is. Baba has gone over there the whole night. I drove in the car, and then I came back, and then I'm taking classes also, kids. Regular classes Baba is taking. Just like Pandu, one batch is starting. You can share everyone, those who are in need of, just they can join for rupees 4,999 only, and you apply code HSP10 HSP10, kids. You can get my mentorship The whole team will give you support. Avengers team support will be with you. You can share it to your friends, your relatives, those who are in need of. You know that we are here to provide you basic education for getting the best marks. Each and everything, the content, the tricks, in-depth knowledge, each and everything we are going to give you. Just for rupees 4,999. What is it? Is a very, very small amount of money, kids. Will you share it to everyone? Now, my dear students, let me come back to the brown hydroboration oxidation. Let me tell you what other things they are going to use. Just see, kids. If I say that CH3, CH double bond CH2, and I've told you the purity was by using B2H6. The purity was 95% pure. I've told you the whole mechanism. Then what they have done, they have used SiA2BH. Then they got 97% pure. Now then they have used 9BBN. What are these things? You must be surprised. What are these 9BBN? Then they got 99% pure alcohol. Now what is the meaning of all these things? The meaning of this is decimal borane, decimyl borane. This is decimyl borane. Now what is that decimal borane? BH. Now amyl means 5 carbons. Amyl means 5 carbon, and iso, sec and amyl. Sec amyl means secondary amyl. How to write down secondary amyl? Just see CH3, CH2, CH. And if I write down iso is also there, sec is also there. S for sec, I for iso, and amyl for 5 carbon atoms. So let me write down properly how to write it. Just see. Iso, first of all, let me write down iso. This is iso. Then I have to write down sec. Let me count 1, 2, 3, 4, 5. Yes. Now this is sec as well as this is iso, kids. Now they see what is the benefit of this. Because of steric hindrance, it will not be able to attack at this carbon. It will finally attack only on this carbon, and that's why the percentage purity is getting increased. Now 9BBN, what is 9BBN? 9BBN. Let me write down B, not over there, the B. This is carbon, this is, let me check it out, boron and hydrogen. This is highly what? Sterically hindered. Now see, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right, it's 9. It's 9BBN. It is too much sterically hindered. That's why they got 99% pure. If they are going to ask very, very tough question, then only they will ask about decimal borane, Ca2BH. Kiranji, welcome. New pandemic attack. I will tell you later on, kids, but right now I want to complete my syllabus, kids, because that is much more important. Then only you kids will get good score. My dear students, let me tell you, I was telling you about Aditya Kumar. He got 702 marks, and AIMS Patna. Why he got? Because he was dedicated student. He has done each and everything according to our Avengers batch. Now kids, this thing I have told you about alkene. Now see, the reaction of HX to alkene. Alkene reaction with HX. Now kids, in most of the books it has been written that it is going to follow Markovnikov's rule. Let me tell you, always follow the mechanism. Don't follow Markovnikov's rule, because sometimes Markovnikov's rule is getting passed, other time Markovnikov's rule is getting failed. So I would like to say, just follow the mechanism only. Just follow mechanism. Nothing else, kids. Just follow mechanism. Why, kids? Let me tell you. Suppose if the examiner has given you this reactant CH2 CH double bond CH2 plus HCl. Now the one who is blindly following Markovnikov's rule, that kid will say that negative part of the reagent goes to that double bonded carbon which is having less number of hydrogen atoms, and he will definitely mark this answer. That kid will definitely mark this as the answer, and he will get failed because this is the minor product. Why, kids? What happened? Actually this H plus will attack on this carbon, and this carbon is delta negative and this carbon is delta positive. What you will get? You will get CH2 CH positive CH3. Now whenever the carbocation is formed, always think about rearrangement, kids. Whenever the carbocation is formed, think always about rearrangement. So you know that right now this carbocation is not having resonance, no resonance. Am I right? Am I making sense? Yes, sir. Stabilized by hyperconjugation. Yes, right. How many? 3 and 2, 5 alpha hydrogen atoms. Stabilized by inductive effect. Yes. What is there? Stabilized by inductive effect. 2 degree carbocation. It is being 2 degree carbocation. So stabilized by inductive effect 2 degree. Why I is going like that? 2 degree carbocation. If from this position 1,2 hydride shift is taking place, so after 1,2 hydride shift, what is going to happen? See, we will get this type CH positive CH2 CH3. Now this is the most stable carbocation because it is being stabilized by resonance. Benzene, phenyl is near to it. Now it will attacked by chloride, and our major product will be definitely this one is going to be the major product, kids. Are you getting my point? So whenever you are writing product, never follow any rule. Just follow one thing, that is the mechanism, because mechanism is the most important thing, kids. Just follow mechanism. Mechanism is more important, kids. So follow it. Okay, kids, you got it? Everyone got it? Just to let me know in the chat section. I want to see everyone got it. Yes, yes, yes. Now, there was mosquito and Baba was playing with the mosquito. Mosquito was disturbing. Mosquito was doing resonance. Now, kids, let me tell you one very, very important reaction. Just see, very, very important reaction. Alkadiene plus Br2 1 equivalent. Alkadiene plus Br2 just 1 equivalent. This is very, very important reaction. It can change your career. It can change your marks. What's that? CH2 double bond CH, CH double bond CH2 plus Br2 1 equivalent. What should be the answer? $1,000,000 question, kids. $1,000,000 question. Now see, kids. Many students are going to get failed over here. See to it. First, Br will attack at this position with the double bond. You will get compound like this. CH2 double bond CH, CH2 Br. Now rearrangement cannot take place because bromonium ion is formed. Bromonium ion. Once the bromonium ion is formed, rearrangement shifting can't take place, but this double bond can move. Resonance is possible, and because of the resonance, what carbocation you will get? You will get another carbocation like CH2 positive, CH double bond C Br, CH2 like this. Now carbocation, this one. So these two carbocations are possible. So the product possibility is, let me tell you, two types of products will be formed. One product is, you know, that one Br has been added over it, second Br can attack over here, or second Br can attack at this carbon. So if it is attacking at this place, you will get Br, CH2, CH2, CH double bond CH, CH2 Br. Now if you see this compound, if you number it 1, 2, 3, 4, or 1, 2, 3, 4, 1, 2, 3, 4, either way. So you just see to it, kids. 1, 2, 3, 4. 1,4 addition product. This is known as what? 1,4 addition product. 1,4 addition product. 1,4 addition product, kids. And this is known as, just see, if it is going to attack on that carbon, you will get CH2 double bond CH, CHBr, CH2Br, 1,2 addition product, 1,2 addition product, kids. Now which product is more stable? Definitely this product is more stable, because see this alkene is having 2 and 2, 4 alpha hydrogens. So this is more stable product, more stable. And the more stable product, and see this is less stable, more stable product is known as thermodynamically controlled product. Remember that. This is TCP. What do you mean by TCP? Thermodynamically controlled product, and it will get formed 80%. And this will form easily. Why it is going to form easily? Because this carbocation is more stable. Carbocation is more stable. Once the carbocation is more stable, so the attack is easy. So this is TCP. No, sorry. KCP, kinetically controlled product. KCP, kinetically controlled. Formation is easy, but yield will be less. Formation will be tough because this is less stable carbocation. To attack on this is very tough, less stable carbocation. So attack is tough, but the yield is more. But remember that this reaction will take place at high temperature or room temperature, because if the same reaction is taking place at -80 degrees Celsius, then the scene will get changed. Then this 1,2 addition means KCP will become 80% and TCP will change to 20%. So what I'm saying, if no temperature is mentioned, then this is the product. Or high temperature is 40 degree. Now you will say, how 40 degree is high temperature? Because if this reaction is taking place at -80 degrees Celsius, then with respect to -80, 40 degrees Celsius is high temperature. Are you getting my point, kids? Everyone just do let me know in the chat section. Do let me know you got it or not, kids. Everyone just do let me know you got it or not. 91 likes, kids. Make it 100. Make it 100, kids. Make it 100 if possible. Now, kids, let me tell you very important reaction, that acidic hydration of alkyne. Just see, Baba will tell you the thing. Just see, kids. First of all, let me tell you, let me solve one question. Just see, kids. Very important. Whatever I taught you, based on that. This is $1 million question, kids. Just see to it. If this question is coming in exam, this will change your life. Why, kids? See. Once they are giving this question, H2O, H2SO4. Once this question. Second time, if they are giving you BH3, THF, water, then H2O2, OH negative. Now, third time, if they are giving you mercuric acetate, CH3, COO, whole twice, Hg, THF, water, and NaBH4, OH negative. Now remember that in 3 cases, if people are there, they will do ring expansion. But remember that here ring expansion will take place here. Then the major product will be this one. Only in this case, the major product is going to be this one. Rest of 2 other cases, no rearrangement cases. HBO reaction, anti-Markovnikov addition. Then this is going to be the product, anti-Markovnikov addition without ring expansion. Remember that, without ring expansion. And this is Markovnikov's, follow Markovnikov's, without rearrangement, ring expansion, it will form this product. So remember this. Now Baba is going to tell you one more very important thing, kids. Can you give me 10 minutes? Just I will complete. I will try to complete within 10 minutes. Kids, show me green hearts if you're ready. Kiran, very good. Everyone just do let me know. Baba is waiting for your answer. Show me green hearts if you're ready, kids. If everyone is ready, kids, show me green hearts. Just show me green hearts. Very good, be positive. Now see, kids, Baba is going to give you fantastic trick. Just see. The same reaction I am going to carry out in alkyne. Just see. This is your alkyne. Now, if anyone is giving you this question, water 1% HgSO4, 40% H2SO4. Now, its mechanism is lengthy. First of all, I will solve with the mechanism. Markovnikov addition. You will get then it is the enol form. Enol is less stable, just 1%. It will tautomerize. It will tautomerize. Now the tautomerism you should know, then only you can do it. So 1, 2, 3. From 1 to 3, hydrogen will transfer and double bond will come over here. And this is going to be your product. This is the mechanism, right? That is 1%, this is 99%. Now, should I tell you my trick? Everyone, just should I tell you my trick? Trick is Markovnikov addition says negative part will go to that double bonded carbon or triple bonded carbon which is having less number of hydrogens. So give this oxygen to this and give hydrogen to this and make product directly. Directly, kids. Directly. You got it? Directly. Now, if HBO reaction is carried out, then anti-Markovnikov's rule will be followed. BH3, THF, H2O, H2O2, OH negative. So what you have to do? Follow anti-Markovnikov, give 2 hydrogen. Let me write down. Otherwise you won't be able to understand. C triple bond CH. Just follow anti-Markovnikov addition. Give oxygen to this, 2 hydrogens to this, and that's it. Nothing to do. Give it to this, and this will be the product. CH3, CH2, CH, CHO. Oh yeah, CHO. Just see. You got it, kids? You got it? You got it? Are you liking the trick? Everyone, just to let me know. Everyone, are you liking the trick? Wow, Kiran, thank you. Thank you, Kiran. Thanks for giving more than 100 likes, kids. Everyone, thanks a lot. Thanks a lot. Thanks a lot, kids. Thanks a lot. Now, kids. Now let me check any reaction is left. Let me check it out, kids. Hey, any reactions left? Yeah, reaction of benzene. Just without that, how it is going to get completed? It will not complete. It will not complete. See kids. That reaction is very, very important. It has changed the whole world. Let's see to that. What reaction is that? This is your benzene having double bond. Now see, 2 reactions are there. And people are always confused in these 2 reactions. Just see, kids. One is, if you react it with Cl2 and what should I write? Anhydrous AlCl3 and dark. So, what do you think? What do you think? What is going to happen, my dear students? What do you think? Definitely, substitution reaction will take place. 6 moles of Cl2 ESR will take place, and all the hydrogens will get replaced by chlorine. All the hydrogens will get replaced by chlorine. So hydrogen has eliminated out, chlorine has taken its place. You got C6Cl6. But remember that, my dear students, where you are going to lose your marks, just see to it. If the reaction is going to take place, 3 moles of Cl2, sunlight, my dear students, 500 Kelvin temperature. So addition reaction will take place. Now the double bond will not be there. Hydrogen will be there. Cl will 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 be there. Double bond has eliminated out. C6H6 Cl6, and this is known as very, very awesome product, Gamaxine. Have you ever heard the name Gamaxine? Lindane, have you ever heard? 666, have you ever seen? Now this is known as benzene hexachloride, benzene hexachloride, BHC. But this name is dangerous name. without benzene. How the name is benzene hexachloride? It's not benzene. It's not benzene, but then also its name is benzene hexachloride because its parent is benzene. So this is the general name, and that is hexachlorobenzene. Its name is hexachlorobenzene. I hope that everyone got it, kids. This is from my side, kids. Do let me know in the chat section, everyone, you got it, everyone, you enjoyed it. Just do let me know, kids, what to say, my dear students. Yeah, it's not aromatic. Let me write down, it's not aromatic. Very important thing. It's not aromatic. It's not aromatic. It's not aromatic. Now I think you got everything, kids. You got everything. Kids, really, you have enjoyed a lot what kids are writing. Let me check it out. Super duper hit. Yeah, definitely. You kids have really seen, given all the best efforts, your hard work, and that is going to change the world. And along with this, I would like to say only one thing, kids. If you can help others, because sharing is caring, you know very well, kids. Sharing is caring. If you can help anyone by sharing this thing, kids, that just the offer price is 4,999, kids. Only valid for 2 to 3 days, kids. Ask them to apply code HSP10 to get my mentorship, to get all the benefits, kids. Because your help can help a lot to students which are in need of support. HSP10, code HSP10. The Avengers batch, get enrolled, ask them to get benefited by getting this batch. Will you help them? Just to let me know, everyone, will you help them? Yes, my dear HSP and Army. Good night to all of you. Bye to all of you. How much did you like this session? How much have you liked this session, my dear friends? I would like to see in the comments once this video is going to get over, my dear friends. I would like to see what actually you have studied, the actual comments in the comment section once this video is going to get off. Will you comment? Will you give your important comments? Yes, sir. Of course, why not? Of course, why not? Sure. Good night, Shubhratri, Shabakhair. All the best to all my dear students. Happy Janmashtami to each and everyone. And my motive is that people, those who are thinking chemistry pedicare adu customer, I would like to say, let's romba sulbam. The things which looks idiyappam murku in chemistry, I would like to say, let's make it romba sulbam. Okay. Arpudham. See, God love you. God bless you. Thank you, Sahana. Thank you, Kiran. Thank you, Kushiga. Manoj Jain. That is Kushiga. Kavin Kumar. Thank you. Jyoti. Thank you. Really, thank you, Jyoti. Kevin. Sahana. Kushiga. Jai Jeevan, thank you, thank you. Akshar, thank you. Definitely I will have my dinner. Thanks to all of you kids. Thank you kids, thank you for making my Janmashtami super duper awesome kids. Shubh, bye. Shubh, bye. Kiran, bye. Kevin Kumar, bye kids, bye. Jyoti, tomorrow's time I will, that will be 8:45 or 8:40. I will keep it like 8:40, 8:30, 8:45. Kevin Kumar, love from Tamil Nadu. Thank you, Kevin, thank you. Sahana, thank you. Thanks a lot, really.